Hello, good afternoon. Welcome to the first webinar of the GEOSYN project, an Horizon project funded by the European Commission. GEOSYN is about geothermal energy solutions for industrial heating and cooling. Really welcome. We will start. The webinar is recorded, so just to let you know that the webinar can be seen also later on. So welcome again. I'm Chiara Pocaterra, the head of projects department in APRE, the Agency for the Promotion of European Research. We are located in Rome, Italy. I'm the coordinator of this project, GEOSYN, working together with the scientific coordinator from the University of Florence. There is here with me all the staff involved from APRE working in the GEOSYN project. I want to thank all of them. And I ask immediately Joanne if you can go to the next slide to present the GEOSYN project. So GEOSYN started the 1st of November last year, so already almost 5 months ago. The contribution of the European Commission is 3 million. We are 10 partners from 5 countries. As I told you, APRE is the project manager, project coordinator, supported and I would say coordinated by the scientific coordinator of the University of Florence. Together with the partners, Consorzio per lo sviluppo delle aree geotermiche from Italy, Gdansk University from Denmark, Geothermal Ukraine, SINTEF from Norway, SINTEF Energy again from Norway, Rivacold from Italy, NeoEco Development from France, and Formaggieria Toscana from Italy. The project is available on Cordis, but we have also our website that is under construction. You will find the landing page, but we are already active in all our social media. Joanne, please go to the next. So the objective of the project, GEOSYN aims to develop a steam heat pump coupled with a heat power refrigeration cycle, working with water to simultaneously maximize the cascade use of geothermal energy, with the option to connect to underground thermal energy storage and operation flexibility. This flexible and extendable solution aims to meet the specific requirements of various industrial sectors, offering advantages such as increased access to geothermal energy, enhanced efficiency, avoidance of environmental hazard, portability, and improved social acceptance. So as you can see in the next slide, so the project is based on 7 work packages beyond the 2, let's say, work packages that make possible now working the project. So the project management from one side and the communication and dissemination on the other side. The technical and research work packages are starting with work package 1 that is covering the first period of the project about geothermal heating and cooling application for industrial applications. This is a framework. We are collecting all the useful and necessary data for the next steps of the project in work package 2 and work package 3 in particular that are already started about the thermal design for optimal energy cascade utilization and the design of our lab scale experimentation. In the second stage, we will test full scale our pilot, and we will start all the activities for the social acceptance and the citizen engagement. In the next slide, you see we are in month 5 now, and what we are doing very briefly, because the colleagues, work package leaders just after me will go deeply in the different activities. we are now identifying the industries candidate to integrate the GEOSYN technology to cover their heating and cooling needs. We are collecting existing practices and feedback of geothermal heating and cooling applications in the industry. We have just now starting understanding how geothermal heating and cooling use impacts on the acceptance and the perception of geothermal. And we have just started the development of numerical models supporting optimal design of high temperature heat pump and heat powered cooling system. And also the development of numerical tools for underground thermal energy storage. We are also started the assessment of integrated system configurations, maximizing the cascading use of residual geothermal heating using the GEOSYN solution. And this is just started now, the detailed design of the GEOSYN solution. So as you have seen, the activities of the first work packages will continue for all the first part of the project. And then in the second part, we will test the solution. So I don't want to keep you on this, let's say, general and of the overview of the project, because as you can see from the agenda in the next slide, we will go a bit in the heart of the first activities of the GEOSYN project. So I'm now, in few seconds, not immediately, leave the floor to Adriano Milazzo from the University of Florence, that is our scientific coordinator. But before this, I would like to go to a Mentimeter. So thank you, Joanne. So you can go to menti.com and you can use the code 3134-1982, or you can use your mobile and use the QR code here on the screen. And I ask you to go to the link. To go to the link, because I would like to ask you a few questions. Because we would like to know the participants, and also to involve the participants in order to understand if you are coming from a research organization, from an industry, and so on. So as soon as Joanne is ready, maybe we can show the first question from the Mentimeter. Okay, you have already, great, thank you. You have already started answering the first question. In one word, what comes to mind when you hear geothermal energy? So there are 26 answers already. Efficiency, steam, clean energy, renewable, great. So we are talking with people that are already aware of geothermal energy, heat. So there are 39 answers. Thank you. Steam. I see also some nice Turkish sauna. Sulfur, dispatchable, high temperature, heating, cooling, green energy. So 42 responses. So almost all the participants. So thank you very much. I think that we should use this image also for our social media. It's really effective on geothermal energy. Thank you very much. So for the next question, Joanne. How familiar are you with the use of geothermal energy in industrial settings? Not familiar at all. Okay, let's see. So, very familiar one. Maybe is one of the partner. So I see that the majority is not familiar at all with the use of geothermal energy in industrial processes, and or maybe they have heard something about it. So it's really important for us to know it, because GEOSYN is really disruptive from this point of view. It's a research project, so there are many things to do from technological point of view, but also from trusting the technology and the acceptability from the social point of view. So maybe I cannot see how many people answered. 22. So maybe we can go to the next. So what is your primary field of expertise? So we know a bit also the audience of the meeting, of the webinar of today. Let's see the answer. Engineering. Geology, geothermal energy. Oh, okay, geothermal energy is increasing. Engineering is the first place. So renewable, so more in general, not really focused on geothermal energy. So maybe next time we have to ask also something more from the other. So energy, engineering remain at the first place, and then geothermal energy. So now the majority answered, so we can go to the next, Joanna. How do you currently engage with geothermal energy? So you are working more on the research and development, on implementation or policy? So the majority of our participants are coming from research and development, but also it's really nice that we have participants that are exploring the potential of the geothermal energy. So 21 participants answered. So let's see if we have another answer. Okay, so next, I see the next. No, I see. Okay, thank you. Do you think geothermal energy can become a mainstream renewable source in the next 10 years? Why? Let's see. If you have ideas, you can type a short sentence. Depends on the region. Okay, so geothermal energy is strictly connected to the natural resources and the territorial resources. Yes, because it is very efficient. Energy security, great potential, depends on cost. Because of the increasing interest in this technology. Okay, possible, but difficult. It's not well known. So this is something else that we are working on in the project. As I told you, it is efficient, but high CAPEX, yes, because it's reliable and not intermittent, because it is a renewable clean source of energy and the next generation after fossil fuels to be shifted. Unlike other renewables, geothermal can offer a base load clean energy resource that can be used for power generation, cooling, and heat utilization. Better regulation for energy sharing. Among countries that cannot produce geothermal energy. Sure. So I think all these are really interesting and relevant. And we can use also for our internal discussion during the implementation of the GEOSYN project. Thank you very much. I think, okay, thank you for the next. What is the biggest barrier to geothermal energy adoption? So drilling cost, initial cost, region availability, so the costs, especially the initial costs. It is not well known, lack of expertise, public acceptance, so the induced, oh, it's very fast. Oh, nice. So thank you for answering. Cost, especially at the beginning, in the investment phase. And then we need also the acceptance, public acceptance. And then expertise is missing, region availability, it's for sure a barrier for the adoption, but also government support, I see policy, incentives, so a bit of many things, economical and let's say of policy and also of public acceptance. So a mix of barriers. So I hope that today will be useful also to answer to some of these, let's say, question or doubts about the barrier and how GEOSYN could or will produce solutions and answer in order to increase also the acceptability of the technology and the resource, because I see also induced seismicity. I think that this was the last slide from Mentimeter.
Yes.
Okay. Yes. Thank you, Joanne. So I think that we could close our Mentimeter. Really, thank you for participating, because are very useful information for all of us, also for the discussion of the today webinar. And I would leave the floor to our scientific coordinator, Professor Milazzo.
Thank you. Chiara, can you hear me?
Sì.
Okay. Would you mind if I share my screen so that I will not have to ask somebody has to change the slides? Okay, let's see if I can do it.
Yes, we can see.
Yes.
Perfect.
Presentation, here's the pointer. Okay. Thank you again. Thanks to everybody for being here. I will very shortly talk you about the technology on behalf also of Sintef Energy. We at the University of Florence and them are working on the technical part, especially from a thermodynamic point of view. We all are thermodynamic people, and the basic choice is using water. I call it with the name that normally refrigeration people use for water, which is R718. It's quite strange way to say water. And why we like to use water? Because it's a natural working fluid. And nowadays, this is a very interesting point, because if something is natural, it is supposed not to do any harm when it is accidentally released into the environment. It has zero global warming potential, zero ozone depletion potential, and what is more important nowadays, it doesn't contain any fluorine, with all the effects that are currently discussed about the potential damage made by some compounds of fluorine. It is non-toxic, not flammable. Here you see a very good competitor of water, which again is called in numbers, as we people in refrigeration like to do. This is ammonia, very simply. And ammonia is a very good fluid, but it is toxic and also flammable. One more thing, it is for sure the cheapest fluid that we can imagine. And from my point of view, it also has the basic advantage of having a very high critical temperature, which makes it very adequate for working at high temperature levels, which is exactly what we want to do with the high temperature heat pump. We have steam coming from the ground in some way, in some forms, and we want to increase the temperature of this steam in order to provide it to any use which needs high temperatures, like cooking something. I'm just saying something very basic, but really the uses may be very big number. Water is very good because it has a very high specific heat ratio, but also poses some points. This is not a good thing. I mean, water has some drawbacks because it has a very high specific heat ratio, very high specific volume of steam, a very low molecular weight, and it boils at 100 degrees Celsius. So when we build a water heat pump, it has a high discharge temperature. You can see here that the compressor, if we try to compress the steam at high pressure, it goes really to unbelievably high temperature. We need a lot of space because the water has a very high specific volume. We need high compression ratio. And if we want to go to lower temperatures, the pressure goes to low values, so we can have air infiltrations. The compression device which has been imagined in this project is a reciprocating piston compressor. This may sound quite surprising to engineers who eventually are listening, because normally we think that for steam, which is so bulky, we need something else. We need, for example, a centrifugal compressor. But the fact is that we are talking about very low condenser duty, very low heating power, which is obviously due to the specific case study which we are talking about, which is a cheese factory in the southern part of Tuscany. But in our view, it's quite interesting because there could be market for small scale heat pumps with quite high temperatures, 180, 20 degrees, and cooling power around, as we say, 50 kilowatts. The temperature lift is an important concept. Is the increase in temperature between the low temperature source and the high temperature sink in which we want to send the heating power. The choice poses a lot of technical difficulties. We need a oil-free compressor, which again is interesting from an environmental point of view, because lubricant oil at such high temperatures could be in troubles. We need to have a limited interstage discharge temperatures. As we have seen, water tends to reach very high temperatures, and this cannot be allowable with some materials, with some constructions. We don't want liquid droplets inside the compressor screen, so we must regulate the machine in order to avoid this. And we also have some troubles at the startup, but probably I cannot go into details given the time that I have. So we started doing thermodynamic simulations. We have several configurations in which we arrive at satisfying the conditions that I have mentioned by, for example, injecting some liquid water between one stage and the following, or by injecting steam before the first compressor. I wouldn't go in detail. Please ask me if you want any further information. There is another configuration in which there is an internal heat exchangers, one more having intermediate heat exchangers that uses the heat available to de-superheat the steam between one compressor stage and the following. There is a final configuration which has been examined in which we have some flash tanks, some tanks containing a liquid which may evaporate and again take care of the intercooling between the stages. All these configurations are being examined. Obviously, some have advantages from one point of view, others on the other point of view. For example, the concept D is the lowest possible risk of having droplets in the stages of the compressor, but has obviously high cost because it has many components. And so this is more or less the situation for what concerns the heating. Let's go to the cooling. For cooling, we were thinking of an ejector. These are the boundary conditions. So let's think to have steam entering at 130, which is the geothermal source. Let's say to have 20 kilowatt of cooling power, and we want to keep, so for example, the room in which cheese is stored at 12 degrees. An ejector is a very simple device in which fast flow entrains and compresses a slow fluid. So basically it's like having a turbine which gets a high pressure fluid and uses it to power a compressor that gets a low pressure fluid, and they both mixed exit on the discharge side. If we model a simple device like this, we would end up with a COP of 1.3. That is the ratio between the useful effect and the energy which is given to the machine in order to produce this useful effect, so the cooling. We have explored again several configurations, and the COP which we get with an ejector is obviously lower. It goes between 0.40, something more than 0.55, 55 according to the configuration. So why we want to use an ejector? Because the ejector is very used in the industry when you have a fluid which can have something in it which is not perfectly clean, I would say. So they are very big machines, very simple machines, and the size is pretty big. So they are not so common because normally they are used for big powers. So why to use them in this situation, because they can easily do with dirty fluids. They are even used with solids, with powders, sorry. And so if you want to bring away some powder from this reservoir, you just use a compressed air, and the ejectors will use it without being damaged. So that's why we are searching about commercial units. This is a catalog from a producer. As you see, they produce ejectors going from 20 to 15,000 kilowatts, so a very large range. This is an Italian manufacturer. We are in touch with them. They proposed us this ejector that could be a candidate for our case study. We also are in touch with a German manufacturer who proposed another unit, and we are evaluating both, or we could even produce our own ejector. We have some experience in designing ejectors. In the past, we have been very fond of this procedure for designing ejectors, which is very old, sorry, and I finished my time. I will go very, very quick to the end. And so we did this prototype chiller in the past, which I used to show you how the ejector behaves. Normally, it has a constant COP up to a certain discharge temperature. And then if the discharge temperature is too high, the performance falls. It is important to have a good surface finish. This is, again, thermodynamic simulations, which shows you the cycle. We have the dimension of the ejector, and we can do, obviously, more refined modeling. We will do it in what follows. The other component which could be interesting is the spray flash evaporator, in which water is sprayed inside a tank in which the pressure is much, much lower than atmosphere. And so the droplets evaporate and give you the cooling power which is required. Again, we don't have a heat exchanger. We have an open chamber which should be more tolerant in terms of presence of contaminants. So that's all. I apologize for being maybe too fast and trying to say too many things. Please ask me if there is something that I could add. Thank you.
Thank you, Adriano. Thank you very much. So, taking into account our agenda, I would like now to give the floor to Dario Bonciani from COSVIG.
Yes. Hello. Thank you, Chiara.
Thank you, Dario. Can you share?
Yes.
Okay.
Yes, I shared the slide. Okay. Can you see it?
Yes. You have to put in presentation mode.
Yes. Okay. Can you see the slide in presentation mode? Yes, good. Hello, everyone. I'm Dario Bonciani. I work for COSVIG, the Consortium for Development of Geothermal Areas, and we coordinate the part of the project related to the geothermal, to promote the geothermal and assess the geothermal heating and cooling integrations in industrial applications in Europe. In this slide, I will present our preliminary review of the opportunities and the existing experiences of geothermal use in industrial applications. Okay, just a premise, why geothermal integration in industrial applications? The use of the energy demand in industrial applications is rising. Because there is an increased production output, but the heat is usually covered, the heat demand is usually covered with fossil fuels, as you can see in this image on the right of the slide. So yeah, around 4% or less of the energy consumed by industrial processes is covered by sustainable energies. The heat sources are often not adequate to satisfy the end user's requirements in industrial sector. The geothermal energy, but geothermal energy is a sustainable and promising energy source to meet the global energy demand. This is an energy source, despite it's not widely used, neither for the space heating and cooling if compared with other energy sources, nor in the industrial sector. Despite this, the direct uses of geothermal heat are quite old in the history and are very versatile, and it's worth to deploy the use of geothermal energy in industrial sectors. However, there are non-technical challenges that we are going to address within the GEOSYN project. The potential end users are end user industries used to have a conservative approach towards the energy transition. So it's not easy to promote to push the energy transition with some industries. There is a lack of awareness on the geothermal potential and the geothermal and the opportunities offered by geothermal energy, and there is indifference, mistrust, and contestations that are the result of the lack of awareness among industries, policymakers, and citizens in general. The objective of our work is to, of this part of the project, is to understand the potential to use integrated solutions for industrial processes. We are identifying industries candidate to integrate the GEOSYN technology. We are collecting the existing experiences on geothermal heating and cooling integration in industries. We are understanding how the geothermal heating and cooling impact the acceptance from the civil society and the perception of geothermal technologies. And we will also define the boundaries and collect data to carry out feasibility studies on the application of the GEOSYN solutions in different case studies. Going more in depth, there is about the identification of industries candidates to integrate GEOSYN technologies. We identified more than 200 potential industrial applications in Europe. So we finalized the mapping of potential industrial applications. And this is the synthesis or a summary of our result. So the most favorite potential end user is the paper sector, followed by chemical, food, dairies, and cement and wood, pharmaceutical sector, and so on. These are, as you can see in the graph on the left side, these are energy intensive industries that can benefit from the application of the GEOSYN technologies, for both generating heat and cool. For example, at the bottom of this table, there are the data centers that is well known, their energy demand to keep the temperature around 18 and 27 degrees, and to do not and to avoid the increase of the temperature of the systems. In next steps, we will go more in depth, and we will interview the industries that we have identified, and we will select 5 case studies to assess the replicability of the GEOSYN technology, and we will collect data to perform feasibility studies and life cycle assessments in virtual case studies. About the mapping that we are carrying out within the GEOSYN project on existing case studies, we mapped so far, we mapped 71 case studies. Most of the applications that we have identified are from the agri-food sector, followed by balneology, let's say, so used for example, for the thermal tourism. Here on the left, you can see a map on the distribution of the case studies, or the different case studies in the world. And here you can see the detail of Europe. The countries that are leading the direct uses of geothermal energy in the industrial processes and balneology are Italy and Iceland. However, we are continuing our research, so this is the state of the art of our research, but the work is in progress, and we are continuing collecting the data. The next steps of this activity are the launching of a survey to identify more case studies of geothermal heating and cooling integrations. So far, we based it on just information from the partners and the information on the literature. But now we are going to publish, to launch a survey. So if you are interested, you are invited to contribute to the survey. We will engage with a selection of the relevant industries to deepen economic, environmental, and social aspects. And finally, we will publish on the project website an open access and friendly and easy to use database, a web database on existing experience, with details on existing experiences. This should increase the awareness on geothermal heating and cooling technologies in industries. About the then we are also aiming to understand the societal impact of geothermal heating and cooling integration in industry. We will analyze the existing experiences in terms of societal impacts on geothermal heating and cooling integrations in industries. We will map the perception of local communities on geothermal energy. And the expected results are a map of citizens' expectations and the local needs on about the geothermal heating and cooling integrations, and the factors that are influencing the acceptance on geothermal energy. This will provide information to the next parts, activities of the GEOSYN project that are more aimed at improving the acceptance and the perception of policymakers and local communities on geothermal energy. This is all from my side. Thank you for your attention. And if you have questions, you can make questions in the chat, or you can write an email to my email address. Thank you.
Thank you, Dario. So if you have question, please put your question already in the chat. We will answer in the final session of the webinar. And now I would like to leave the floor to Paride Gullo from the University of Southern Denmark about the heat pump specifications. Paride?
Yes. Can you hear me?
Yes.
Yep.
I can hear you. Now I see also you.
Yep.
Can you share?
Yep.
Yes. Thank you.
Okay, so good afternoon and thanks a lot for being here. So I'm Paride Gullo and today I'm going to talk about the GEOSYN heat pump specifications. So the agenda is basically about talking a little bit about the GEOSYN heat pump and then introduce some specification regarding the heat source and evaporator for the heat pump, heat sink and condenser for the for our heat pump, and then compressor, and finally talking about the heat pump as an overall device. Let's put it this way. So if we start from the a brief introduction regarding the heat pump we want to develop and demonstrate in this project, I have prepared a simple schematic. So basically, the idea is to use the a geothermal reservoir as a heat source for our GEOSYN high temperature heat pump, and our high temperature heat pump will rely on water as the sole refrigerant. And the idea is to use the heat sink to generate heat above 190 degrees Celsius. And this heat will be used for different industrial process applications. That's our target. And the idea is to develop this heat pump and demonstrate and achieve a TRL of 5 within the GEOSYN project. The next step is to talk a little bit about the heat source and the evaporator specifications for the GEOSYN heat pump. So first of all, I would like to mention that our heat pump will be installed in a geothermal reservoir in Tuscany, so in Italy. And the idea is where the geothermal will have basically a heat source temperature at the inlet of 110, 130 degrees Celsius, something about this. This will lead to an evaporating temperature between 105 and 125 degrees Celsius. And the fluid, the secondary fluid that we will use will be basically steam. If we focus now on the heatsink, the condenser specification for the GEOSYN heat pump, basically the idea is to install heat pump whose heating capacity at the design condition will be around 50 kilowatt. That's the target we have in mind. And the idea is basically to implement a heat pump which will be able to generate heat between 190 degrees Celsius to 1210 degrees Celsius, leading to a condenser temperature from 195 degrees Celsius and 215 degrees Celsius. And again, and the temperature lift will be around 80 Kelvin. That's our target, more or less. And again, as a secondary fluid, we are going to use steam. When it comes to the compressor is a novel compressor, and the idea is basically to use a brand new compressor, which is variable speed, and it's based on the piston technology. And the compressor will be oil-free, and also it will allow reaching a discharge temperature up to 250 degrees Celsius. Last point, the GEOSYN heat pump specification. So the few words about the heat pump as an overall device. The idea is basically, okay, the schematic that I have in this slide here is not the final layout that we are going to use in our project. That's still a work in progress in somehow. So the idea is to have, of course, condenser, expansion valve, and evaporator. But when it comes to the compressor, the idea is to have 3-4 stages. We are still working on that, and then use some intercooling technique between this compressor, the different compressor stages, basically. Again, as I said, the idea is to use water as the fluid, the refrigerant for the high temperature heat pump, and the aim is to provide a COP which will be above 3. That's the target. And I would like also to mention and highlight that the idea is to implement also a solution which is also which will be very flexible, and the focus will be mainly on the optimal startup time and also ramp up rate. And this will be basically the main tasks for the University of Southern Denmark. So thank you.
So now I ask to the next speaker, so to Giuseppe Vitri from Rivacold, to talk about our case study.
Yes.
Giuseppe?
You can hear me?
Yes, but I cannot see you.
Wait a moment.
Mm-hmm.
I share my presentation.
Okay, we see the presentation.
This is in.
Okay. And we
okay?
see you. Okay, thank
Okay.
you very much.
Okay, I can start. Good afternoon. Thank you for the introduction. My main responsibility in Rivacold is to evaluate the new refrigeration technology to develop more efficient and sustainable product. So this is the main reason because we participate at this kind of project. Rivacold is in the industrial partner in this kind of project. And I spent some slide to understand who is Rivacold. Rivacold is born in 1966, is for manufacturer for small condensing unit. Today is a very large company. This is our number, 330 million euro of turnover. More or less 1,700 employees. And this is a big area to have the manufacturing and stocking area. Our range of product is in refrigeration system, heat exchanger, and the truck refrigeration. And we work, especially today, in the natural refrigerant at the moment with the propane and the CO2, and I hope in the future also with water. Also, the product range move in the for the specific application. We have a big range also for the application in the refrigeration system. So the market is very big in the refrigeration. It's possible to see some example. To close the presentation of Rivacold is very important for us also our laboratory for the research and check the efficiency of refrigeration system, and to test the performance and the certification concerned to the safety. In the GEOSYN project, our objective is to make the heat pump, high temperature heat pump, and the cooling system. This is the first step. The second step is to test in our lab the performance in the specific condition to evaluate the real performance. After this step, we have the real installation on the field, and after it's possible to see the history data and the real working condition of the system. The case study is located in Tuscany, close to the geothermal power plant. We have an industrial factory for cheese. where we have a steam line from the near geothermal plant, where the steam line is used in the industrial factory for the cheese. We would like to take one part of this kind of steam to test our new system. The first step before to have the prototype is important to have the monitoring of the steam line. So we need to understand the real situation. This is the layout of real situation on the field. We have one line with the water, liquid water, come in the geothermal power plant, and in the geothermal power plant is present the heat exchanger and come back the steam. Just 1 week ago, we put in the field some sensor to understand which is the real situation. So we have a flow meter, a sensor temperature, air pressure. This is some picture of the monitoring, where is possible to see we are located the sensor. Just to now is possible to see have the information, also the history data of the pressure, temperature, and the flow. This is the base to have a correct design of the heat pump. The heat pump, the concept we showed before for the other presentation, the base for us, we need to follow the design with this kind of capacity, 50 kilowatt in heating. We would like to have a lift of 80 Kelvin. We need to have 4 stages of compression, oil-free for the reason shown before, because we use piston compressor. And it's very important to have a system with a correct reliability. This is the range we showed also before. We would like to increase the temperature. The lift is 80 Kelvin, so we would like to have a steam around 180-200 degrees Celsius. But also we need to design, with the support obviously from the university, to design and to make the cooling system. This is the specification, only 20 kilowatt, but with reactor technology. Shown before from Milan. After the first prototype, when is ready, before to come in the field, we test all system in the lab. In this way, it's possible to test the specific condition on design, and it's possible to investigate also outside. In this way, it's possible to understand the behavior of the total system. From our side, the one of the next step is the real installation on the field, where it's possible to see the real condition. And on the field, we have the prototype, obviously, but also the control device and the supervisor system. In this way, it's possible to have the data and to have the history data in the real condition. Last step, with the data collection, is possible to evaluate the behavior of the modeling, not only the heat pump and the cooling system, but also the total system. And this way it's possible to correct or give the comparison with the simulation. Thank you. For Riva Cold Repeat is very interesting project. In this way, we will provide to have a new solution to meet the increasing market demand for sustainable and efficiency. Thank you.
Thank you, Giuseppe. Now I would like to leave the floor to Taras from Geothermal Ukraine.
Yeah,
about the environmental assessment, citizen engagement, and social acceptance. Taras, I leave you the floor.
Good afternoon, everyone. Can you hear me well?
Yes, we can hear you. Now I can see you, and the presentation is also, we can see it. Thank you.
Okay, thank you, everyone. So today we'll be speaking about the environmental assessment, citizen engagement, and the social acceptance, which is the task under the NGO Geothermal Ukraine. A few words about our organization. We are the non-profit NGO, which who work on development of geothermal potential and fostering innovation for geothermal application in Ukraine. Yeah, please, next slide. Within the working package, we'll be working on the next milestones. So basically, we will be developing the training materials for industrial engagement cafe. We'll be working on online info session with the policymakers and authorities, as well as a report on the survey to assess the new level of acceptability and trust. Within this task, we will working on the deliverables, preparing such an engagement strategy, report on social engagement strategy to attract investment, as well as reporting on advanced sustainability assessment, and last but not the least, the policy guide with a recommendation. And the relevant KPI will be also described additionally. Please, next slide. So within this working package, the next objectives will be working on. So the first is the developing and implementation of the engagement strategy for industries, citizens, policymakers. The second is about promotion of awareness on the reliability of the technology to the enhance public acceptance and trust and increase the likelihood of its adoption. The third is about the performance of sustainability assessment in the light of do not significant harm principle. And the last fourth is about informing policymakers and authorities towards the integration of geothermal heating and cooling in the industrial sector. Next slide, please. Within the scope of work, the task number one, engagement with the social, civil society and policymakers under the leader COSWIC will be started since month 10th of the project. The task two is engagement with the industry stakeholders with leader of Geothermal Ukraine will be started since month 18. Within the subtask women entrepreneurship under the upper leadership. The third is advanced sustainability assessment, the LCA taking into account do not significant harm principle and environmental. The leader is University of Florence, and the fourth is a policy recommendation and information is the leader of APRE. Will be started in a month 28. Next slide, please. So the first task it's about the engagement strategies. So within this activities, we will be defining which actions to undertake and which methodologies to apply to move from the level 1 to the higher level for acceptability and trust. So basically, within this activity, we are planning at least 2 awareness campaigns focused on the specific thematic within like targeting citizens and industrial stakeholders. At least 2 mobilization and mutual learning workshops involving social communication and local authorities, both in Italy and Ukraine. So we also initiate the survey with the questionnaires to assess the new level of acceptability and trust. So basically to be both applied for the industrial and the citizen target groups. And the last one is about the result from social engagement activities which will be used to improve communication to industries and citizens under the policy recommendations. The next slide, please. So the task 2 about engagement of industry stakeholders and women entrepreneurship. So basically the women entrepreneurship task is to inspire the young women through female role models to study and take up careers in entrepreneurship and geothermal heating and cooling. So basically this is the the initiative to promote the geothermal among the female new generation to get more interested in that kind of activities. So these role models are mainly targeted to overcome the barriers to the women entrepreneurship and can teach girls and women to how to successfully doing this business. So, and planned activities within that is a social media campaign, at least 3 online informative sessions will be applied within the different role models to overcome the barriers, as well as developing and informing infographics. The next slide, please. So about the task 3, advanced sustainability assessment, basically the goal is to conduct a sophisticated environmental assessment by selecting appropriate indicators to prepare the procedures to comprehensively evaluate the overall performance of the innovative GEOSYN project in light of the do not significant harm principles. So basically within that goal, we will assign the system within industrial case studies, and the GEOSYN technology will be performed. Detailed examination will be carried out to identify the irreversibility and inefficiencies at the component level. In the realm of advanced environmental assessment, the system LCA will be conducted following internationally recognized harmonized guidance, and complete life cycle inventory will be relocated at the component level of the proposed system. So as a result, we will compare it to other renewable-based systems, including traditional hydrothermal geoenergy, in terms of cost per unit of the proposed energy service. The next slide, please. So the task number 4 is about the policy recommendation and information. Though within the starting date of 1st of February 2027, and this task aims to elaborate the policy recommendation document as a result of all the overall project reference. So within that, we will be targeting to make the literacy information on geothermal heating and cooling, recommendation on how policymakers and authorities can replicate the GEOSYN, supporting measures to raise awareness and acceptability, and information on market support and financial frameworks. So within that, we will working on the documentation within the presentation to regional and national relevant policymakers in Italy and Ukraine. At least 25 person has to be involved within 2 online info sessions. The second target is the fine-tuned document to be presented during the final event of geothermal of the GEOSYN project. And the last third is about infographic, which will be developed and translated into English and other 5 languages of the consortium. The next slide, please. So within the deliverables, we are planning to work with 5 deliverables. The first is engagement strategy. The second is a report on social engagement. The third is a strategy to attract investment to adopt GEOSYN in industrial sectors. The fourth is a report on advanced sustainability assessment, and the fifth, the last one, is a policy guide with recommendations. Thank you. Next slide. Okay, so thank you for your attention, and we'll be happy to answer on any question if it arises.
Thank you, Taras. I see many questions in the chat for question and answer. So I would start for all of the speakers. So there is a question to Giuseppe. This solution looks very expensive. Do you have any goal of the payback time for the solution? I think that the question is for Giuseppe, but maybe if any of the speakers has an answer.
I try to give you an answer, but in the at the moment it's not possible to give you the payback because we need to define the real efficiency, and depends of the specific case. So it's not so easy to give a general answer because the payback depends obviously the technology, but also which is the application.
Thank you, Giuseppe. A question for Paride. Which working fluids are you considering in the heat pump you presented?
It's water. So we are going to have water in both cycles, high temperature heat pump and the heat-driven ejector chiller.
Again, so they say to Paride, will you not cool the source further down than 100 degrees Celsius with the heat pump?
I can answer to both questions, I guess, from also Pierre. So the numbers I showed are just preliminary numbers, so they are not the final ones. Let's put it this way. And as Giuseppe said, Rivacol installed the measurement equipment 1 week ago, and that experimental measurement equipment has the aim to give us an idea about the characteristics of the steam in the geothermal reservoir we are going to use. So we might cool down further down than 100 degrees Celsius. That's a possibility. And first, when it comes to sensible heat or not sensible heat, then again we need to see what we have in the geothermal reservoir first. But of course, we will also take into account this possibility to cool down more the steam from the geothermal reservoir. But first of all, we need to understand, investigate a little bit more about what we have in the what we are going to use basically as fluid, secondary fluid.
Thank you, Paride. There is a question for Dario. What is the scale of the graph over different sectors you showed, Dario?
Okay, yes. We are considering, I don't know if I have understood the question, but we are considering industries.
The scale of the graph.
Yes, we showed two different graphs of industry sectors. The graph related to the potential end users considers industries at European level, and the cases of about the existing experiences of geothermal integrations considers both European level and global level, but of course we are focusing more at European level. We identified for the potential end users, we identified 207 potential end users. And for the case studies, for the existing case studies, we have identified 71 case studies. But of course, we have to conclude our research. So this is work in progress, and we will consider, I think we will have more case studies of geothermal heating and cooling integrations in industries, both in Europe at a global level. But concerning the local communities, we are considering we are making the mapping of the perception of geothermal technologies in Ukraine and in Italy.
Thank you, Dario. There is a question for Adriano. How do you mitigate the high investment cost in such a system with 4 compression levels, for example, for a system as small as 50 kilowatt hour?
Kilowatt thermal, I guess.
Kilowatt,
well,
thermal, sorry.
That's a very good question. Thank you for answering, for asking. I will try to answer, but well, obviously the prototype we are building will be very expensive. It's very, very obvious, given that it is a single unit. The choice of using a reciprocating compressor, I must confess that at first when we ended up with this solution, I was pretty surprised because reciprocating compressor is very far from this kind of applications. But honestly, if we could use components deriving from mass production, because obviously reciprocating compressors, even multi-cylinder reciprocating compressor, are very common in the industry, we could try to lower the price. The fact that a reciprocating compressor is typically multi-cylinder makes it pretty easy to have a multi-stage compressor. Obviously, it must be modified, but in some way it is not far from the present situation. I'm reasoning on a pretty long-term perspective. It is obvious that instead of 50 kilowatt, it is 200 kilowatt machine. Things are much better. But for now, we also have obviously experimental problems, limitations in the test system provided by Rivacold. So it is on purpose a very small size, just to show that it is technically feasible. From an economic point of view, I would say that a lot of work needs to be done, and yet I feel that it could be a useful work as far as we may install such systems in large numbers. I don't know how large. I mean, if it is not a matter of doing one installation, but having a smaller system, we may do 10 or 20 installations around Europe. It could make sense. Obviously, I realize that the schemes that I have shown are very complicated. We must find out a way to make them a little bit more simple.
Thank you, Adriano. There is a question for Joanna. We will get the slides.
Yes, both the recording and the slides will be available after the webinar. I'll send a follow-up email with the link to everyone who attended today. Thank you.
Thank you, Joanna. So another question for Adriano. What type of compressors are you using for steam compression? What are the prospects of water-based heat pump when temperature at compressor inlet are lower, like in the shallow geothermal case?
Yes, this question is very related to the previous one. Again, we are using a reciprocating compressor, and I don't feel very much worried about the lowering of the temperature, which could cause subatmospheric pressure inside the machine. For sure, we need to have some system to get rid of any air infiltration. Actually, I didn't talk about, but the startup procedure, as it has been imagined now, as starting the machine with air. So the machine must be robust with respect to air infiltration. So I don't see any problem in going below 100 degrees Celsius. Personally, I wouldn't like to have another stage for the lower temperatures in order to avoid subatmospheric pressures. I don't see it as a big problem, actually, but let's talk about it.
Thank you, Adriano. So the question are finished, so I don't see other questions. Let me check also in the chat. No, I don't see other questions. Maybe in here, no. So I ask to the speakers, to the colleagues, if they want to add something else. In general, so otherwise, I think that we can close. See, Dario?
Yes, if I can remark our call to write us to report if any case study that are using geothermal energy in industrial processes and production processes, so including the agri-food, for example, greenhouses or chemical sector, pharmaceutical, and so on. Every kind of production processes that are using geothermal energy, this will be very appreciated because this will help in increasing the awareness of potential end users, so increase the trust, and to increase the awareness of policymakers, so to promote policies to promote geothermal energy, and increase the acceptance on geothermal energy. Yeah, thank you.
Thank you, Dario. So I think that we can close our first webinar about the GEOSYN. So other will follow, but you can, in the meantime, follow our activities and results through our website and especially our social media. So follow us and share also the information. You will find, as Joanna said, the recorded webinar and the presentation also online, and that's all from our side. Thank you very much.
Thank you. Bye-bye.
Thank you.
Thank you.
Bye-bye.
Thank you.
Bye-bye.
Bye-bye. Bye-bye.